Hi there. I thought I'd like to show you how I actually run and operate the 8mm scanner and how I set it up and how it actually runs. So what we have here is the full setup with the Arduino in here, power management in this box, the lamp, the film gate, the hacked camera, and the output spool, and then this is the take-up spool. The film goes through the film gate as driven by the servo here, and every time this little switch is closed, the Arduino sends 5 volts to the camera to take a picture. So to get it to run, all you have to do is insert the film in here, then turn on the lamp, the camera, and the Arduino, and not turn on the servos right now because you have to set up the film path first. But as it now happens, I have set it up already, so I'll just turn on the servos and you will hear a chirping noise for a while, and then I will attach the film to the take-up spool. So I turn on the servos, and the camera is doing nothing at the moment because this is the black leader tape. It doesn't have any images on it. You just have to guide the film along a little so that it passes along the proper trail. This is just a lens cleaning cloth that I have here to protect the film. This servo is rotating, but I'm not running it into this take-up spool at the moment because I need to fix this end to the line that I have at the take-up spool first. So we'll just wait for a while and see how it goes. The cool part is that I can interrupt the operation of this machine at any time merely by turning off the servos, and the rest of the machine will just wait until it gets the servos back online. This is nice if I have to go somewhere for a while. So we are approaching the end of the take-up spool. Just a few more frames. This little knob here governs the speed of this servo, so I can actually turn it off if I want to. But now the film is out there long enough and I can just turn off the servos. And here we have it. Turn on the servos, turns up some speed from the pot, and we are getting nice and smooth movement of the film through the machine. And now we will wait for this little frame here to pass through the film gate so we can go and set up the camera. That will take another couple of minutes actually. Some of the bits and pieces floating around, of course, because this is a lab. The previous version also had no control over the speed of the take-up spool, which was a major problem because sometimes the film is rather tight and I can just stop the film from getting pulled through the film gate a couple of frames at a time, and that is a major asset here. I'm also designing a limit switch that goes in here that will automatically disconnect the servo for a couple of seconds if the film goes too tight, but that is still in the works. I will now readjust the camera so that you can see what happens at the camera end. Now the first frame of the actual film has been passed inside the film gate. And now I will turn on the camera using the Canon Hack Development Kit operating system, which is loaded by starting it into a gallery mode, then going into the menu, and is replaced with the actual Canon Hack Development Kit. Now I can do everything I want to, like zoom in and make sure the frame is in place, take a test picture here. And now when I press the Alt key and start the script, I can refocus once more, and then by pressing the menu key, the machine is now waiting for the Arduino to give it pictures. So I will now just turn on the servos, and as you can see, every frame is grabbed and counted. The Arduino is also counting the frames, and in the next phase I will add a display on top of the Arduino box to show me that I have the same amount of frames in both settings, in the camera and in the Arduino, and then I will know that I have not been skipping frames or I don't have any double frames. Now I will just cover it up so that there is no extra ambient light that comes into the system. And this is basically it. I will just let it run. It takes about an hour, 2 hours to grab a 4-minute film. I'm taking 40 pictures a minute, and I'm quite happy with that speed. And this is how it looks on the inside. The Arduino is flicking a red LED every time it takes a picture, and here we can see the pictures. Okay, the film is almost run out. Only about 20 images left, and you can see the high-tech ambient light cover that I put together just to make sure that the exposure is measured from the lamp and not from the ambient light. And in a few moments I will let you see how the film actually runs out. Oh well, might as well do it now. So the final images are now going to enter the film gate, and after that I will show you how to rewind the film. The rewind feature is a new one, and it enables me to do it much better. And now all that remains is to switch the spools and then turn the potentiometer all the way to the other end. So I have another structure here. This is the regular spool. This is the one that I now see how I have printed these parts that I can use to make a tight connection between the axle and the actual spool. So with this I can just take it off. And this was actually printed so that I had a piece first, and then in Blender I took a M4 nut and with a Boolean operator I took it off from the cross, and the measurements are so tight that I just pressed it in. I did not even need to have any glue in there, and it works fine. So we'll switch the spools like so, add the tightener, like so, and then the other end of the axle, which also has an M4 screw, sorry, nut in it. This goes in here, and then the other spool is placed on another axle. This would be easier if I had somebody actually filming this thing, but I will just have to live with this. Place this one here and pull the film around. Placing it in the requisite hole in here, and turning it by hand a couple of times first so that it actually would stick, which it didn't. I need this one. So just find the hole again, which is there. Pull the film through, press it in the hole like so, and then turn on the servos, but this time that way. And this is the rewind phase. This is somewhat boring to watch, but while it's doing that, I will disconnect the camera and the lamp, take out the memory card, and go play with Blender to get these images done. I'll see you there in a moment. The final step in going from the actual analog film into video files is going into Blender and using its video editor to give you the MPEG file. Now to do that, you go into the video editor and then you go into add image. Then you locate the folder where you have your images, which is here. It's going to take a little while to load. And here we have the files. All you have to do is to press the A key to load everything into the timeline in Blender. Now we will set up some settings, like first of all the screen size and the 100% render output, the frames. Frame rate per second is 18. Then we check that we are doing an MPEG file with RGB as the color space. And if you wanted to add sound, you could add an audio codec and add a soundtrack to it, but I'm not going to do that. And in the TMP folder, I will call this 2016b .mpg. This is going to be the name of the file that I'm going to create. Now you need to add a transformation strip because this is flipped, but with the transformation strip you can flip it, and you can also then crop it. And while you are cropping it, actually it's a better idea to go into the files itself. When you go in here and you will, let me find a good place here somewhere. Okay, this is a nice image for this. I will then just add a left adjustment and the bottom adjustment and the right adjustment. And now I can easily see that I need to rotate the file or the timeline like so. Now it's perfect, and then just move the black out of it. Top a little more, bottom a little more, like so, and left a little more. Okay, so this is going to be the final frame. And for this demonstration purposes, I'm going to render from this frame for about 250 frames, which I can set up here. I will say the start frame is 505 and the end frame is going to be 750. That gives me a nice demonstration piece of this film. And now that all of this has been set up, I only have to press the animation key and Blender starts rendering the file. As you can see with my laptop, it's not the fastest possible, but if you have a nice NVIDIA graphics display adapter, it works. It's like blazingly fast in that case, but I will just cut it. I'll just cut the recording for a moment. And now the rendering is finished and I have a file in the temp folder, and this is how it looks. So as you can see, it is not perfect, but then again, this is 8mm film and exposures are slightly off all the time, but you get the point, you get the nice retro feeling and the soft glow of having actually pulled it off at least to this presentable condition. So this is how it's done, and if you have any questions, just drop me an email to my website, which is www.sabulo.com. See you there.